You'll thank yourself later for watching this before your interview. What are the disadvantages of neural networks? Answer: neural networks have several disadvantages. One of the main issues is the black box problem, where it's difficult to understand how or why the network produced a certain result. This can be frustrating when the network makes an incorrect prediction, such as identifying a dog as a duck. Additionally, building a neural network model can take a long time, and it requires a lot of computational power and data to train. This can make it challenging to use neural networks in certain situations, such as when working with limited resources or tight deadlines. Overall, while neural networks are powerful tools, they are not without their limitations. What is the learning rate in the context of neural network models, and what are the consequences of having a learning rate that is too high or too low? Answer: the learning rate is a number that ranges from 0 to 1 that determines how quickly a neural network learns from the data it is trained on. A higher learning rate means the network learns faster, but it may also cause it to overshoot the optimal solution, leading to poor performance. On the other hand, a lower learning rate means the network learns more slowly, which can lead to a longer training time, but it may also result in a more stable and accurate solution. A well-chosen learning rate is crucial for achieving a good balance between learning speed and accuracy. If the learning rate is too high, the network may not converge to the optimal solution, while if it is too low, the network may not learn quickly enough to adapt to the changing data. A good learning rate should be chosen based on the specific problem and dataset being used. What is the learning rate in neural network training models, and how does it affect the model's adaptation and learning process? Answer: the learning rate is a crucial hyperparameter in neural network training models that determines how quickly or slowly the model adapts to a given situation and learns. A higher learning rate value indicates rapid changes and fewer training epochs, while a lower learning rate value may lead to slower convergence or even getting stuck on a poor solution. As a result, finding the optimal learning rate value is often done through trial and error, as it can significantly impact the model's performance. A well-chosen learning rate can help the model converge to the desired output, while an ill-chosen learning rate can lead to suboptimal results. What is a deep neural network? Answer: a deep neural network is a type of artificial neural network that has many layers between the input and output layers. It's called deep because it has a higher number of layers than units in a single layer. This allows it to capture more complex patterns and create more accurate models by adding more and larger layers. The more layers, the deeper the network, and the better it can learn and recognize patterns in data. What are the different types of deep neural networks? Answer: there are several types of deep neural networks, including feed-forward neural networks, radial basis function neural networks, multi-layer perceptrons MLP, convolutional neural networks CNN, recurrent neural networks RNN, modular neural networks, and sequence-to-sequence models. Each type of network has its own unique characteristics and is suited for specific tasks, such as image recognition, speech recognition, and natural language processing. For instance, feed-forward neural networks are used in facial recognition, while convolutional neural networks are used in computer vision. Recurrent neural networks are used in natural language processing, and modular neural networks are used in breaking down large problems into smaller chunks. Sequence-to-sequence models are used in text processing when the length of the input text differs from the length of the output text. These questions are great, but can you recall the right answers under pressure? That's where MLQ Café comes in. Practice real-world and CQ, track your performance, and build confidence one quiz at a time. Start your 15-day free trial now at MLQscafé.com. Now let's get back to the next question. What do you mean by end-to-end learning? Answer: end-to-end learning is a deep learning process where a model is trained on raw data without any intermediate steps. Instead of breaking down the task into smaller steps, the model learns to perform the entire task simultaneously from input to output. This approach eliminates the need for manual feature engineering, which can lead to biased results. It's like a driverless car that learns to navigate and make decisions based on input without needing human intervention at each step. Similarly, in speech-to-text, the model generates a written transcript directly from an audio clip without requiring manual processing of the audio data. End-to-end learning enables the model to learn and perform complex tasks more efficiently and accurately. What is gradient clipping, and how does it address the problem of exploding gradients in deep learning? Answer: gradient clipping is a technique used in deep learning to address the problem of exploding gradients, which occurs when huge error gradients build up during backpropagation, causing massive modifications to neural network model weights. This technique involves limiting the gradient values to a specific range, usually by clipping them element-wise to a minimum or maximum value. This helps to improve numerical stability during training, preventing the model from becoming unstable due to excessively large gradients. While gradient clipping does not significantly impact the performance of the model, it is an important technique to ensure stable training and prevent the model from diverging. What are forward and back propagation in the context of deep learning, and how do they work together to fine-tune a neural network? Answer: forward propagation is the process of calculating the output of a neural network by propagating inputs through the network, layer by layer, until the final output is reached. It's like a one-way street where the inputs flow through the network and the outputs are calculated at each node. Backpropagation, on the other hand, is a technique used to fine-tune the weights of the neural network by propagating the error information from the output layer back to the input layer. It's like a two-way street where the error information flows backwards through the network, adjusting the weights to minimize the error. Together, forward and back propagation work in tandem to train a neural network by first calculating the output and then adjusting the weights to improve the accuracy. This process is repeated multiple times to fine-tune the network and achieve the best possible results. What is data normalization, and why is it necessary in data processing? Answer: data normalization is a technique that transforms data into a standardized format, making it easier for models to process and analyze. It's necessary because it ensures that all variables have equal importance, preventing one variable from dominating the model's performance due to its larger scale. Normalization also helps to improve model precision by converting values to a similar scale without distorting the range of values, making it a crucial step in data preprocessing. What are the different techniques used to achieve data normalization in data preprocessing? Answer: there are three main techniques used to achieve data normalization: rescaling, mean normalization, and z-score normalization. Rescaling involves multiplying each data point by a constant term to scale the data within a specific range. Mean normalization uses the mean of the observations to normalize the data. Z-score normalization, also known as standardization, uses the z-score or standard score to normalize the data. These techniques help to reduce the effect of different scales and units in the data, making it easier to analyze and compare. What do you mean by hyperparameters in the context of deep learning? Answer: in the context of deep learning, hyperparameters are variables that determine the architecture and training process of a neural network. They are set before training the model and influence how the network learns and adapts to the data. Examples of hyperparameters include the number of hidden layers, the number of hidden units, the learning rate, and regularization techniques. These hyperparameters are crucial in determining the performance and accuracy of the model, and their optimal values need to be carefully tuned to achieve the best results. What is the main difference between multi-class and multi-label classification problems? Answer: in multi-class classification, each sample belongs to only one class, whereas in multi-label classification, each sample can belong to multiple classes. In other words, multi-class classification assumes mutually exclusive classes, whereas multi-label classification allows for overlapping classes. For example, in a multi-class classification problem, an image can be either a cat or a dog, but not both. In contrast, in a multi-label classification problem, an image can be both a cat and a dog, as in the example of an image depicting both a cat and a dog. This difference in assumption leads to different approaches and challenges in modeling and solving these types of classification problems. What is transfer learning in the context of deep learning, and how does it help in training machine learning models? Answer: transfer learning is a technique in deep learning where a pre-trained model is used as a starting point for a new task, leveraging the knowledge and features learned from a similar task. This allows the new model to learn faster and more accurately, especially when there is limited data available. The pre-trained model's weights and features are fine-tuned for the new task, enabling the model to adapt to the new data while still retaining the knowledge gained from the previous task. This is similar to how humans can apply their knowledge of riding a bicycle to operating other two-wheel vehicles, making it a powerful tool for quickly training machine learning models. For instance, a model trained for autonomous automobile driving can be used for autonomous truck driving, reducing the need for extensive new training data. Transfer learning is particularly effective in situations where there is limited data, allowing for faster and more accurate model training. What are the advantages of transfer learning? Answer: transfer learning offers several advantages, including a better initial model, a higher learning rate, and higher accuracy after training. In traditional methods, a model is created from scratch, which can be time-consuming and may not perform as well. Transfer learning, on the other hand, allows us to start with a pre-trained model that has already been trained on a similar task, giving us a head start. This enables us to learn faster and achieve higher accuracy in the new task. Additionally, the pre-trained model serves as a better starting point, allowing the model to converge at a higher performance level, resulting in more accurate output. Overall, transfer learning provides a more efficient and effective way to train deep learning models. Can a neural network model be trained if all biases are set to 0? Additionally, is it possible to train a neural network model if all weights are set to 0? Answer: yes, it is possible to train a neural network model even if all biases are set to 0. However, setting all weights to 0 makes it impossible for the model to learn, as the neurons would learn the same features in each iteration, resulting in poor performance. This is because the derivatives for each weight would remain constant, preventing the model from adapting to the task. Any constant initialization of weights, not just 0, can lead to poor results. What is a tensor in deep learning? Answer: in deep learning, a tensor is a multidimensional array that represents a generalization of vectors and matrices. It's a fundamental data structure used to store and manipulate data. Each element in the tensor has the same data type, and the data type is always known. Tensors can have any number of dimensions, and their shape can be partially or fully known. Most operations on tensors produce fully known tensors, but in some cases, the shape of a tensor can only be determined during graph execution. In simple terms, tensors are like supercharged matrices that can handle complex data structures and operations in deep learning models. What is the main difference between a shallow neural network and a deep neural network? Answer: the main difference between a shallow neural network and a deep neural network is the number of hidden layers they have. Shallow neural networks have only one hidden layer, while deep neural networks have multiple hidden layers. This difference affects the way the networks learn and represent the input data, with deep networks being able to learn more complex than abstract representations of the data. Additionally, deep networks are more efficient in terms of the number of parameters and computations required. How can you improve the constant validation accuracy in a convolutional neural network CNN? Answer: constant validation accuracy in a CNN can be improved by splitting the dataset into 3 sections: training, validation, and testing. This helps to prevent overfitting, which occurs when the network only memorizes the training samples. Additionally, you can experiment with the neural network's parameters, increase the size of the training dataset, use batch normalization, implement regularization, or reduce the complexity of the network to achieve better generalization and improve the validation accuracy. What is batch gradient descent and how does it work? Answer: batch gradient descent is a type of gradient descent algorithm that calculates the gradient of the loss function over the entire training set at each step. This means that it computes the gradient using all the training data at once, which can be computationally expensive for large training sets. However, it is ideal for convex or smooth error manifolds. The algorithm updates the model parameters by subtracting the gradient multiplied by learning rate. Batch gradient descent is suitable for problems where the number of features grows, as it scales well in such cases. It is a simple and effective algorithm, but it can be slow for large datasets. What is stochastic gradient descent and how does it differ from batch gradient descent? Answer: stochastic gradient descent is an optimization algorithm that calculates the gradient of the loss function using a single training sample at each step. This approach is faster and less computationally expensive than batch gradient descent, which calculates the gradient using the entire training dataset. The stochastic nature of SGD can lead to bouncing around the minimum value, but this can be solved by lowering the learning rate. The main differences between the two algorithms are: batch gradient descent is deterministic slow and computationally expensive, whereas stochastic gradient descent is stochastic fast and less computationally expensive. Additionally, SGD is more suitable for large training samples and has a better chance of escaping shallow local minima. However, it may not provide the best solution and can be slow to converge. Which deep learning algorithm is the best for face detection? Answer: while there are several deep learning algorithms for face detection, it's difficult to pinpoint a single best one. However, convolutional neural network CNN are widely used and effective for this task. Some notable examples of face detection algorithms that use CNN include FaceNet, probabilistic face embedding, ArcFace, CosFace, and SphereFace. Each of these algorithms has its own strengths and weaknesses, and the choice of which one to use depends on the specific application and requirements. What is an activation function, and what is its purpose in an artificial neural network? Answer: an activation function is a mathematical function used in artificial neural networks to introduce nonlinearity into the network's output. Its purpose is to determine whether or not a neuron should be stimulated by calculating the weighted sum of its inputs, adding bias, and then making a decision based on the result. This nonlinearity is essential for the neural network to learn complex patterns in the data, as it allows the network to learn functions that are not linear combinations of its input data. In other words, the activation function enables the neural network to recognize and learn complex relationships between inputs and outputs. What does the term epochs refer to in the context of deep learning? Answer: in deep learning, an epoch refers to the number of passes a deep learning algorithm makes across the entire training dataset. This means the algorithm has gone through the entire dataset once, and the number of epochs is often used to measure the progress of the training process. For instance, if an algorithm has completed 10 epochs, it has gone through the entire dataset 10 times. What are the different types of activation functions used in artificial neural networks (ANN)? Answer: there are two main types of activation functions used in artificial neural networks (ANN), sigmoid function and hyperbolic tangent function (TAN). The sigmoid function is a nonlinear activation function used in feed-forward neural networks, particularly in the output layer, to predict probability-based outputs. On the other hand, the hyperbolic tangent function TAN is a smoother and zero-centered function with a range of -1 to 1, used in some deep learning models. Both functions are differentiable and have positive derivatives everywhere, making them suitable for use in neural networks. What is the formula for the output of the TAN function, and why is it more widely used than the sigmoid function in multilayer neural networks? Answer: the formula for the output of the TAN function is fxi equals x/sum sin jx1. The TAN function is more widely used than the sigmoid function because it provides higher training performance and gives a zero-centered output, which helps with backpropagation. This is particularly important in multilayer neural networks, where the output of one layer is used as the input for the next layer. The zero-centered output of the TAN function makes it easier to train the network and improve its performance. What is the softmax function used for in deep learning architecture? Answer: the softmax function is most commonly used in multi-class models, returning probabilities for each class, with the target class having the highest probability. It is used to output a probability distribution over multiple classes, making it a crucial component in many deep learning applications. What is the main difference between deep learning and machine learning? Answer: deep learning is a type of machine learning that uses neural networks to analyze and represent complex data, whereas machine learning is a broader field that uses algorithms to learn from data without being explicitly programmed. The key difference lies in the complexity of the data and the depth of the neural networks used. Deep learning is capable of handling large amounts of data and complex relationships, whereas machine learning is more suitable for structured data and smaller datasets. What is dropout, and how does it help in machine learning? Answer: dropout is a regularization technique used in machine learning to prevent overfitting. It randomly drops out neurons during training, which helps the model learn independent representations and improves its generalizability. This means the model becomes better at making predictions on new, unseen data rather than just memorizing the training data. A dropout value of 20–50% is recommended, with 20% being a good starting point. A low dropout value has little effect, while a high value can cause the network to underlearn. Dropout is particularly effective in larger networks, where it can lead to better results. What are the applications of autoencoders? Answer: autoencoders have several applications, including image nursing, dimensionality reduction, feature extraction, image colorization, and data compression. Image denursing involves removing noise from images. Dimensionality reduction reduces the number of features in the input data. Feature extraction learns important hidden features. Image colorization converts black and white images to colored ones, and data compression reduces the size of the input data. However, autoencoders are not suitable for lossless compression and can only compress data that is similar to the data they were trained on. What are autoencoders? Explain the different layers of autoencoders. Answer: an autoencoder is a type of neural network that replicates the input data in an unsupervised way, with the output layer having the same dimension as the input layer. It consists of three main layers: the encoder, the code, and the decoder. The encoder compresses the input image into a lower dimensional representation, known as the code, which is then fed into the decoder to reconstruct the original input. The decoder is a feed-forward network that reassembles the input from the code to its original dimensions. The autoencoder's goal is to provide an output that is identical to the input. What do you mean by exploding and vanishing gradients in the context of gradient descent, and how do they affect the training of a neural network? Answer: in the context of gradient descent, exploding gradients occur when the updates to the weights and biases become excessively large, causing the weights to overflow or become non. This results in unstable training. On the other hand, vanishing gradients occur when the updates become excessively small, resulting in minor or negligible changes to the weights and biases. This can lead to slow or stagnant training, where the model fails to converge to the optimal solution. Both exploding and vanishing gradients can hinder the training process and affect the performance of the neural network. How does recurrent neural network backpropagation vary from artificial neural network backpropagation? Answer: recurrent neural network backpropagation differs from artificial neural network backpropagation in that each node in recurrent neural networks has an additional loop, which incorporates a temporal component into the network, allowing for the capture of sequential information from data, whereas artificial neural networks do not have this temporal component, making them unable to capture sequential information. This additional loop in recurrent neural networks requires a modification in the backpropagation algorithm to account for the sequential dependencies between nodes, making it distinct from the backpropagation algorithm used in artificial neural networks. What is the difference between bias and variance in the context of deep learning models, and how can a balance be achieved between the two? Answer: in deep learning models, bias refers to the difference between the model's predicted values and the actual values, leading to inaccurate predictions. On the other hand, variance refers to the variability of model predictions for a given data point, indicating the model's complexity. To achieve a balance between the two, a model should aim for a low bias to avoid underfitting and a low variance to avoid overfitting. This can be achieved by adjusting the model's complexity, regularization techniques, and hyperparameters to find an optimal trade-off between the two. A model with low bias and low variance is likely to generalize well to new data and make accurate predictions. Which model is more powerful, a two-layer neural network without an activation function or a two-layer decision tree? Answer: a two-layer neural network without an activation function is more powerful than a two-layer decision tree. This is because the neural network can consider more attributes while building a model, whereas the decision tree can only consider 2 or 3 attributes. The neural network's ability to consider more attributes makes it more powerful for complex and nonlinear functional mappings between inputs and response variables. Can a deep learning model be solely built on linear regression? Answer: yes, a deep learning model can be built on linear regression, but only if the problem is represented by a linear equation. In this case, each layer in the network can use a linear function as its activation function. However, if the problem is a composition of linear functions, a deep network is not necessary, as a linear function can already solve the problem. Adding more layers to the network in this case will not improve the model's predictive capacity. How do you decide the number of neurons and hidden layers in a neural network architecture while building one? Answer: there is no one-size-fits-all rule to determine the exact number of neurons and hidden layers required. However, you can start with a basic systematic experimentation approach, considering the problem domain and previous expertise with neural networks. You can also begin with a simple neural network architecture and gradually increase its complexity based on predicted output and accuracy. The size of the hidden layers should be somewhere between the size of the output layers and that of the input layers. The input neurons' weights are 40, 5, and 6, respectively. Assume the activation function is a linear constant value of 3 for the activation function. What will the result be? Answer: to find the result, we multiply the input neurons' weights with the activation function 3. So the result will be 4 * 3 equals 12, 5 * 3 equals 15, and 6 * 3 equals 18. Therefore, the result is the sum of these values, which is 12 plus 15 plus 18 equals 45. However, the options provided are 32, 64, 96, and 128. Since 45 is not among the options, the correct answer is not among the given choices. Therefore, the correct answer is none of the above. What is the size of the input image in the kernel/filter after transformation? Answer: the input image has been transformed into a 28x28 matrix, which means it has been resized to a 28x28 pixel image. The kernel/filter is also 7x7, which means it is a 7x7 matrix that will be used for convolutional operations. The stride of nan is not applicable in this context, as stride refers to the number of pixels the kernel/filter moves when performing convolution, and nan is not a valid value for stride. In most cases, the stride is a positive integer that determines the amount of overlap between the kernel/filter and the input image. If the stride is not specified, it is usually assumed to be 1, which means the kernel/filter moves 1 pixel at a time. However, in this case, the stride is explicitly mentioned as nan, which is not a valid value. Therefore, the question should be revised to clarify the intended meaning of the stride. What will be the size of the convoluted matrix in a convolutional neural network CNN for a given input image of size 10x20? Answer: the size of the convoluted matrix will depend on the size of the kernel filter used in the convolutional layer. Typically, the kernel size is smaller than the input image size. For example, if the kernel size is 3x3, the output feature map will be 20-3 plus 1 x 20-3 plus 1 equals 18x18. If the kernel size is 5x, the output feature map will be 20-5 plus 1 x 20-5 plus 1 equals 16x16. Therefore, the size of the convoluted matrix will be 18x18 or 16x16 depending on the kernel size you used. Which of the following options represents the correct sequence of steps involved in employing a gradient descent algorithm? Answer: the correct sequence of steps in employing a gradient descent algorithm is 1. Initialize the model's parameters. 2. Calculate the loss function. 3. Compute the gradients of the loss function with respect to the model's parameters. 4. Update the model's parameters in the direction of the negative gradients. And 5. Repeat steps 2-4 until convergence or a stopping criterion is reached. This process allows the model to iteratively adjust its parameters to minimize the loss function and achieve optimal performance. Calculate the difference between the actual and predicted values. Answer: the difference between the actual and predicted values is the error or residual. It is calculated by subtracting the predicted value from the actual value. This helps to measure the accuracy of the prediction model. For example, if the actual value is 10 and the predicted value is 9, the error would be 1 10 9 equals 1. This error can be positive or negative, indicating whether the prediction was higher or lower than the actual value. The goal of a prediction model is to minimize the error and make more accurate predictions. What is the goal of repeating a process until the best network weights are found? Answer: the goal is to find the optimal set of weights for a neural network that minimizes the error between the network's predictions and the actual outputs. This is typically achieved through an iterative process, where the network is trained multiple times with slight variations in the weights, and the best weights are selected based on the performance of the network. The process is repeated until the network's performance converges or reaches a satisfactory level. How do you retrieve the output values from a neural network? Answer: to get values from the output layer, you need to pass an input across the network. This means you provide an input to the network, and it will propagate through the layers, performing calculations and transformations until it reaches the output layer. The output values are then generated and returned. In other words, you feed forward an input through the network to obtain the output values. Create a random weight and bias. Answer: a random weight and bias are generated by creating two random numbers. The weight is a random number that is multiplied by the input to the neuron, and the bias is a random number that is added to the output of the neuron. This is done to introduce randomness and variability in the neural network's behavior, allowing it to learn and adapt to different patterns in the data. For example, a random weight might be 0.3 and a random bias might be 0.1. These values are then used to calculate the output of the neuron, which is the weighted sum of the inputs plus the bias. This process is repeated for each neuron in the network, allowing the network to learn and make predictions based on the patterns it has seen in the data. What is the purpose of backpropagation in a neural network? Answer: backpropagation is an algorithm used to modify the values of neurons in a neural network to reduce the error between the network's output and the desired output. It works by tracing the error backwards through the network, identifying which neurons contributed to the error, and adjusting their values to minimize the error. This process is repeated until the error is minimized, allowing the network to learn and improve its performance. In the given context, the neuron's values are modified to lessen the error, which is done by backpropagation. What does a Boltzmann machine encompass? Answer: a Boltzmann machine is a type of neural network that encompasses a fully connected network with both hidden and visible units, asynchronous operation, and stochastic update. This means that the network has a complex structure with many interconnected nodes, operates in an asynchronous manner, and updates its weights and biases randomly. This unique combination of features allows the Boltzmann machine to learn complex patterns and relationships in data, making it a powerful tool for modeling and solving complex problems. If we want to forecast the probabilities of n classes PON, PO, PK, which of the following functions can be utilized as an activation function in the output layer so that the sum of P overall n equals 1? Answer: the correct answer is softmax. This is because the softmax function is used to convert the output of a neural network into a probability distribution, where the output values are non-negative and sum up to 1. This is particularly useful when we want to predict the probability of a class or category, as it ensures that the probabilities are valid and add up to 100%. The other options, ReLU, Zigwide, and TAN, are not suitable for this purpose, as they do not guarantee that the output values will sum up to 1. From the input layer to the hidden layer, the maximum number of connections is less than 50. Answer: since the input layer has 10 nodes and the hidden layer has 5 nodes, the maximum number of connections between the input layer and the hidden layer is 10x 5 equals 50. Since the question states that the maximum number of connections is less than 50, this means that the actual number of connections is less than 50. This could be due to some connections being missing or not present. Which of the following gives nonlinearity to a neural network? Answer: rectified linear unit ReLU is the correct answer. This is because ReLU is a nonlinear activation function that helps the neural network learn complex relationships between inputs and outputs. It introduces nonlinearity by allowing the output to be 0 or positive, but not negative. This nonlinearity is essential for the neural network to learn and represent more complex patterns in the data. The other options, stochastic gradient descent and convolution function, are not related to nonlinearity in neural networks. Stochastic gradient descent is an optimization algorithm used to train neural networks, and convolution function is a type of neural network layer, but neither of them introduces nonlinearity. Therefore, the correct answer is rectified linear unit.